I saw there's a flag here that says run processor. If I say false, I just want to make sure that if I build it, I will not see anything here. I do not. Okay, awesome. Okay, before I begin though, let's go ahead and explain how did I get the analyzer to run. So if you look at any of the projects, you can see under analyzers, you will see the lib. So there are two things. One is how the Stride Core NuGet package will be including the DLL and thus enabling the analyzer for all transitive dependencies in the NuGet chain. So this is the stuff here, where we include the DLL straight away packet into the NuGet package under this directory. And that's that. So that was simple. Now, in order to have every project in the solution reference the code generator, that was more complicated. So basically, the code generators the projects in the Stride solution all reference this thing, Stride core props. Now, do the tests do it as well? Let's see. They have its own stuff. Yeah, they import core Stride core props, but they build from core, so they don't take the dev solution props. Okay, so this means I need to copy over this thing here. So I'll just go ahead and say what this does. Okay, so basically I have created a props file here, which all it does is, if you're not the compiler services project, because cannot reference itself, make a project reference to that project and include it as an analyzer and don't reference the assembly. So what this means is use this project only during the compilation as an analyzer. And because this props file is included in the core props and the UnitTest props now, it will be included in every project in that that's using those props, and like they all are for the most part. So hopefully that should work. Yeah, cool. So let's go ahead and compile tests, and I should see a warning. This is a test. This is my current test that this thing actually runs. I made a print test, which basically just emits a warning. Right, initialize takes a selector, and then for each field, it gets a selector. So here, for example, we can see that there's a member serializer class which serializes a member, creates a serializer for a member, and then here for the parent, we just get serializer for the parent class, and then we'll do the serialize, and that will be the base. And then once we do that, they will also want to generate this file, which basically what it does is it registers the serializers in the assembly registry. So when we actually go to the serialization context, like in the test we did, let's see, here we did binary serialization writer. This thing here, let me remember. Okay, right, so this thing has a serialization context, which has the serialization selector. And then the selector is doing the initialization, as well as it has a hook, I believe, or maybe it doesn't. But it had a hook. Anyways, the point is, oh yeah, here, register serializer selector. And then this thing has a hook, this one. So basically, whenever a new assembly is loaded, I think this one. No, this one. Okay, this one. Whenever a new assembly is loaded into the assembly registry, it will call this callback and pull out the registration from this class into this data serializer factory. Now, in our case, we actually don't need to initialize anything. So the way the generators work is initialize is called once per execution environment. Which for us will be either the CSC, the C# compiler, or it will be the IDE, so Visual Studio. The source generators allow you to register a callback, which on any syntax change is called, and you can do stuff in the runtime basically. So for example, there's this concept of incremental generators that I'm not going to be using, which allow you to, as you type code, run the generation. And this is useful when, let's say, you have an attribute, right, which dynamically generates properties, and in your code you will be using those properties. So the moment you modify the attribute or something, it has to regenerate it live for you to be getting the IntelliSense for those new properties. But for my usage, I just want to run it during the compilation itself, because we don't need it before that, right? So I'm gonna be populating this baby. Yep, there you go. Yeah. Yep. Awesome. Okay, so this works. Well, or maybe you can warn here as well. Let's not fail on this. Yeah, cool. I'm curious if would the member, like, does the type symbol have a a location for it. Um, yeah, locations. Hmm. Cool. Um, I don't know if a property can be partial, but even if we just can get the first on that, cool. Okay, URL reference with no members and base with one member being URL string. Okay. And then we've got the test. Yeah, for each we got a type nicely. Okay. A has I int, B has A and I. Okay. C has also children and URL. Right. Can I check the access type one? Here we get p full, p get, pi full, f full, fi full. Okay, so the get set one. I forgot about this part. Um, right. So for properties, um, if prop dot get method uh, right, so set method is if set method is null, um, and prop dot type uh, is not value type. Well, yeah, if it is value type, then continue. Um, structs have to be assignable properties. Okay. Okay, and then uh, if it doesn't have a get method, I would say scrap it, right? Yeah. If prop get method is null, continue. Um, a serializable property has to have a get method. But like even with those, like the serializers for those types are defined in stride core, right? We can see serializers primitive type serializers. There you go, Boolean, for example, right? So it would be good if I could, because like also mind you, float, for example, is not annotated with anything, which means that I would have to walk the factories um, of Stride core in order to see this attribute and be like, yeah, that um, that is there. Yeah, see, type of byte array, this type of the serializer. Yeah, so this would have to be readable to me from different compilation units. Okay, so to sum up what I did today, I have managed to process the syntax tree of an assembly during the compilation. I was able to iterate over all the classes and their members and choose the classes that implement DataContract or who are descendants of a class that implements DataContract with the inherited flag, and then go through the members and select those that are actually interesting to us. Yeah, so I think that's a decent amount for today. And tomorrow I will be trying to get the step one generating the classes. Well, I mean, I could probably do that today as well. Like that's the easy part for the most part, you know. For each of the type spec, emit a class. That's quite easy. And this I did already. So yeah, this will be important. So actually, maybe I can go ahead and add that. So this thing will have this thing would be ordered. Right. So mind you that in this code, the fields were processed first and ordered first. Now I don't have this beautiful offset thing here. I would have to do it by hand. So instead I'll just add a to do. All right, thank you very much for people watching. That's it for today. I'm exhausted. It was quite a nice piece of work so far, and hopefully I can finish it by the end of the week. So see you over the next few days.